Welcome back, guys. Concept 22.1 says the Darwinian revolution challenged traditional views of a young Earth inhabited by unchanging species. So we're going to take a little history lesson because in science, as well as many of your other subjects, the history of what you're studying is very important to understanding the actual information. So to set the stage, we're going to retrace some of Darwin's quest to explain the adaptations, the unity and diversity of what he called life's endless forms most beautiful. We're going to find that Darwin was the type of scientist who was very detail-oriented. He collected reams and reams of data and examples of animals and fossils, and in his thinking, in his work, he was trying to put together this idea, this explanation for what he saw. Darwin's idea had deep historical roots and was influenced by the work of others as well as his travels. He was not the first to have some of these ideas, and as a matter of fact, there were some other scientists at the exact same time as Darwin who were working on some of the same concepts, but he is generally considered the father of the idea because he was the one who was first to publish a major book, and he was the first to really make these ideas concrete, even though there were others that influenced him and there were others that worked along with him about at the same time. So here's a little timeline that we can take a look at. We're going back all the way into the 1700s. Darwin was born in the early 1800s, right here in 1809, but you can see prior to the birth of Darwin, there were other people that had an influence later in Darwin's life. One of those people that you might have heard about is Lamarck, which we'll discuss him in just a moment. Lamarck had his own hypothesis about evolution, which now turns out to be, based on the information we have, not the correct way of viewing it, but Lamarck was one of the first scientists to hit upon some of the ideas that are correct in evolution. There was also actually an economist named Malthus, who we'll talk about Malthus. He had some famous essays on the principles of population that later affected the thinking of Darwin. We have some other people with some names in here, Cuvier that you'll see, Lyell. These guys are various geographers or geologists, and we'll talk a little bit about how they influenced Darwin. Here we have Darwin's travels around the world. He spent multiple years on a ship called the HMS Beagle, and it traveled around the globe exploring South America and the Galapagos Islands, and then basically circumnavigated the globe all the way around. He spent a lot of time in the Galapagos Islands. We'll talk about that. Early on, after his travels, Darwin did write a long essay on his ideas of descent with modification, but we'll find that he never published those ideas. He didn't publicly speak out about it. Darwin was the type of scientist who was very careful, very precise. He collected reams of data to back up his idea, but he was still hesitant to actually go public with this idea because he knew that it would be problematic for a lot of people. He knew that this was a different way of thinking, and that for some people, particularly in religious circles, there might be a problem with this way of thinking. And we're going to find out that Darwin himself had started out his life potentially studying to become a clergyman. His wife was fairly religious, and these were issues that Darwin as a person grappled with as he was coming to his understanding of what he found. So then we will get to the publication of The Origin of Species in 1859, and then some of the last few things that we'll talk about toward the end of the 1800s. So this is basically just kind of a quick overview of Darwin's life, or the times of Darwin, the things that affected his thinking and that went into this publication of this famous book on the origin of species. We can actually start our study of the idea of evolution long before Charles Darwin. Even going back into some ancient philosophers, Greek and Roman philosophers, there were several ancient philosophers who suggested or thought that life might have changed gradually over time, that things were not fixed in place. But the Greek philosopher Aristotle, who perhaps was the most well-known and influential of the ancient philosophers, he did view species as fixed, and he arranged them on what he called the Scala Natura. I have no idea if I'm pronouncing that correctly, but we'll say I am. The Scala Natura, the scale of nature. He suggested that creatures were fixed in their position, that they had been created as is, and he placed them on a scale or a ladder, basically. He said they were fixed in their position, perfect and unchanging. And then, of course, we have various religious texts, like the Old Testament of the Bible, holds that species were individually designed by God, and that therefore they were perfect and unchanging. And so the view was, at the time, up up into the 1800s at least, for most people, including scientists of the time, that creatures are as they have always been, that the creatures were created in their present form and that they were unchanging. A good example is a very well-known scientist, Carolus Linnaeus. You may recall that Carolus Linnaeus is the person who developed the binomial naming idea, nomenclature that we use to name genus and species, and he developed a system of naming living creatures. Well, Carolus Linnaeus interpreted organismal adaptations as evidence that the creator had designed each species for a specific purpose. So he did note these various adaptations and how creatures fit their environment, but he felt like that was evidence that God or a creator had designed each species for that specific purpose. Linnaeus is the founder of taxonomy, which is something we'll talk about a little bit later. Taxonomy is the branch of biology concerned with classifying organisms and putting them in their particular place. He developed the binomial format that we were just talking about for naming species. For example, humans or Homo sapiens, that is our genus and species name, and we'll discuss that a little bit further. So this was a very well-known and well-respected scientist who had this same idea or thought that creatures were as they had always been, unchanging and created by a god or a creator for a specific purpose. As we discuss the history of these ideas, you'll find that it's not just biology that comes into play. Geology in particular was very important to the changing ideas of scientists at the time. The study of fossils definitely was very important to help lay the groundwork for Darwin's ideas. Fossils are remains or traces of organisms from the past, usually found in sedimentary rock, which appear in different layers or strata. Fossilization is not a common occurrence. For a fossil to occur, that creature had to have died in an area generally near water, a lake, a pond, a stream, an ocean, because that's where sedimentary rocks are going to form. If this creature died high in the mountains, it's not likely that those bones would become fossilized or any of the remains would become fossilized. So fossils will never show us the complete picture of past life, because fossilization is a relatively rare occurrence, and then there is the matter of finding those fossils. So you have, not only is fossilization fairly rare, but then the finding of certain fossils is an arduous task that is fairly rare as well. The fossils found in particular strata or particular layers of sedimentary rock, they provide a glimpse of some of the organisms that populated the earth at the time that those layers were formed. So when you look in a certain layer of rock and you find fossils of certain creatures, that can tell you, at least in that instance, that that creature was around at the time that that layer of rock was created, and that may be thousands, millions of years ago. A great example is looking at the Grand Canyon. If you've ever been to Arizona and the Grand Canyon, I have not yet made it out there, but it's certainly on my list of things to do. You can certainly see that there are many, many layers or strata of the rock. So you have the river, the Colorado River, running through the bottom of the canyon. And at one time the river was much higher, and it wore its way through the rock over magnificent amounts of time. And if you go down through these layers, each of these different layers, variations, you can see these stripes, the color changes, they represent many, many, many years of time as you go down. In the textbook it shows a good diagram right here, the formation of sedimentary strata with fossils. So it says, number one, rivers carry sediment into aquatic habitats such as oceans and swamps, and over time that sediment builds up. So here we have a river flowing into, say, an ocean area, and the sediment that the river carries gets dumped into this ocean area, or it could be a large lake or swamp, and that sediment builds up in layers over time, forming what we call strata. Over time, those layers become compressed and form solid rock. Some of those layers may contain different fossils. Then what can happen is, as the water levels change and the bottom surface is pushed upward or the bottom layers are exposed, we may find some of those fossils. So later on, this river or this ocean may be gone, but perhaps now there's a new river cutting through the land, and as that water works its way down, much like in the Grand Canyon, suddenly it reveals these various layers, these strata, and we may find fossils in these layers. The closer to the top the layer is, the more recent it is. The further down toward the bottom, the older the stratum and the older the creatures, the fossils that you find. The science of paleontology, which I'm sure you've heard of if you were a little kid like me and you were fascinated by dinosaurs and fossils, you know what a paleontologist does. Paleontology, the study of fossils, was largely developed by a French scientist, George, I'm not even sure how to pronounce the first name in the French, but Georges Cuvier. And Cuvier noted that the older the stratum, meaning the lower it was, the more dissimilar its fossils were to current life forms, that if you compared the fossils in the older layers, they matched less to currently existing creatures. He also observed that from one layer to the next, sometimes new species appeared and other species disappeared, that it wasn't just a continuation of the same creatures, that you would find different creatures in different layers, and they didn't always appear in all of the layers. He inferred that the extinctions that occurred that caused this, they must have been pretty common, because he saw a lot of this where species would be in one layer or one set of layers but not in the next, and new species would appear that weren't in the lower layers. So he thought that this extinction process must be pretty common, and his idea, he advocated what's called catastrophism. Catastrophism is a speculation that each boundary between the strata where you see these changes represents some major catastrophe that occurred, a giant flood or earthquake or some other massive event that caused these changes. So catastrophism is the principle that events in the past occurred suddenly and were caused by mechanisms that are different from those that are operating in the present. In other words, what happened in the past is not what's happening now, and that when you see these changes, it was because of these major events that we don't often see going on today. Let's contrast Cuvier's idea of catastrophism with the idea that two other geologists had similar to the time frame there. One of these geologists was James Hutton. He actually lived pre-Darwin, before Darwin was around, and the other geologist was Charles Lyell. Lyell was a contemporary of Darwin. He was alive at the same time, and Lyell in particular, his ideas had a major effect or impact on Charles Darwin. Both of these geologists perceived something different than Cuvier did. They perceived that the changes in the Earth's surface result from slow, continuous actions that are still operating today. So their idea, Lyell's principle, was called uniformitarianism. There's a big long word that you can use in your next Scrabble match. Uniformitarianism. And this states that the processes that changed the Earth that they saw geology-wise were long and slow and were the same processes that were in action today. That the mechanism of change are constant over time. And this idea of uniformitarianism really had a strong influence on Darwin's thinking. And Darwin tended to agree with this because it lined up better with what he saw as he traveled around the world. He also agreed that if geologic changes resulted from slow, continuous actions rather than these sudden catastrophic events, then that must mean that the Earth must be quite a bit older than what was the widely accepted age at the time of a few thousand years. It would, for example, take an extremely long amount of time for a river to carve the Grand Canyon by the process of erosion. So Darwin also later reasoned that if these processes, these long, slow processes, could affect geology, perhaps something similar, such as a slow, subtle process, could cause the biological changes that he saw throughout his studies of fossils and other creatures. So Lyell proposed that the same geologic processes that are operating today they were operating in the past and at the same rate. And that's quite a bit different than this idea of catastrophes, things that occurred suddenly and that are not happening in the same way today. So Darwin latched on this idea of Lyell's, and he was not the first to apply this idea of gradual change to biological evolution, but he was the person that we most know today. So what we're going to take a look at now is some of the other people who, in a biological sense, kind of latched on to these ideas of change over time. Some of them added information that we still find useful today, and some of them, their ideas have been discredited to some degree or changed to some degree, but it's still valuable as part of the history of where we got to. So the first person we're going to look at in that regard is Lamarck, French biologist Jean-Baptiste de Lamarck, and we'll take a look at him in just one second. So this is a name you've probably heard before, Lamarck, French biologist Jean-Baptiste de Lamarck. He was alive prior to Darwin, 1744 to 1829. He was a biologist and scientist, and he was a believer in two principles that are important to his theory here. One of them is called use and disuse, and he was not the only person to think this, but his idea or principle of use and disuse was creatures, the parts of their bodies or their characteristics that they used most often would become strengthened, and the parts that they use less often would become lessened or weakened in some way. And then he also believed in something called the inheritance of acquired characteristics, which basically meant that what a creature did in its life would affect what it passed on to its children. And kind of a silly but a specific example would be, for example, thinking if a woman at age 22 gets a tattoo of a heart on her left arm, that her child at age 25 would be born with a tattoo of a heart on its left arm. That would be sort of a similar idea to the inheritance of acquired characteristics. So let's take a look at what Lamarck said. Lamarck hypothesized that species evolve through use and disuse of body parts and the inheritance of acquired characteristics. And although the mechanisms that he proposed are unsupported by evidence, his thinking did open the door to further explanation and discovery regarding evolution. So he did feel that creatures changed over time, but the mechanism that he suggested is really not what we know to be true today. A good example is giraffes. Lamarck said that giraffes would be born in the beginning, say for example, with a somewhat shorter neck, but their entire lives giraffes were always stretching and stretching to try to reach leaves that were higher up to get more food. And so the giraffes would stretch and stretch their neck, and throughout their life, as they used their neck and stretched it, their neck would actually grow and become longer over time. And then those giraffes would pass on that longer neck characteristic to their offspring, that they were driven by this inner need to grow a longer neck, so that they would pass that on, and the next generation would have slightly longer necks, and they too would stretch and then pass on a slightly longer neck, and they too would stretch until you got to where you saw the giraffes of today with this extremely long neck. So this idea, his mechanism, his way of evolution turned out not to be correct. We know that that's not the way it works. We know that the genetics that are passed on are set basically from the birth of that creature. So this giraffe, if he has the genetics for a short neck, those are the genetics he passes on, no matter how much he stretches throughout his lifetime. So the mechanism that Lamarck used was perhaps incorrect, but his ideas of how creatures change over time were helpful. Here's a good example. This is a gardener tending a bonsai tree, and this shows you how these acquired traits cannot really be inherited in the way that Lamarck thought. This bonsai tree is trained to grow as a dwarf by pruning and shaping and processing so that it looks like this massive full-grown giant tree, but in a 3-foot tall version of it. Well, the seeds that come from this tree, if you were to let them grow naturally, they do not grow into a 3-foot dwarf version. They would grow into a normal sized tree. So the traits that the tree acquires in its lifetime are not passed on via its genetics. Now there is something that we have talked about a little bit in the past called epigenetics, where the environment can affect to some degree the genetics that are already present. That's still slightly different than what Lamarck what he was saying. So while epigenetics does kind of nod toward this idea of environment affecting genetics, it's not in the same way that Lamarck suggested. So this epigenetics is how environmental factors can play a role in the on and off of genetics that are already there, but that's not the same thing that Lamarck was saying. So his ideas were good in a way, but not completely supported in a way as well. So we're going to stop right there. We'll get on to concept 22.2 and talk more about Darwin himself. We'll take a break, come back in just a second.